Okay, we have here today another interesting integral from the MIT integration bee from 2006, problem 11. We have the integral from 1 over pi to 1/2 of natural log 1 over x dx. Okay, to get started with this, the thing I notice is we have this 1 over pi 1/2, but then we have 1 over x inside, so everything is kind of flipped. So what that makes me think is what we could do is simplify this by making a u substitution, because that's going to flip everything around and make it a little clearer. Now, I probably wouldn't do it this way on an exam, so I think it's going to be slower, but it's going to make it a little clearer and easier for me to show. So we'll do the substitution, setting u equal to 1 over x. And then from this, we'll solve for x, just rearranging, taking reciprocals. So we're going to have x equal to 1 over u. I'll take my derivative, and for dx, we're going to find this is going to be minus 1 over u squared du. So then we'll go ahead with the substitution, plugging in 1/2 here, that's going to flip it and give me 2 here. And then plugging 1 over pi in, that's going to give me pi for the lower bound. And then here, this is going to become natural log of the floor of u, and then dx is going to be this minus 1 over u squared du. But then what I'll do with this minus sign, I'll take it out front of the integral, and we'll just use this to flip the bounds. So we'll flip this so that we have the higher value pi up here, and we'll have 2 for the lower bound. But then from here, what I find useful with the floor function is if we can split up our integral with integer bounds, it's going to be a little easier to deal with. And pi is not an integer, right? Pi is like 3.14 and a whole bunch of decimals, but we actually have 3 in between 2 and pi. So what we'll do is we'll just break this up on 3. So for the first integral, we'll go from 2 to 3, ln floor of u times 1u squared du. And then for the second one, we're just going from 3 to pi, and we'll have the same exact integral. Then the nice thing now is what's going to happen with the floor with integer bounds. It just becomes, these values are going to become constants. This one here too, because the floor is going to round us down to the next highest integer. So whenever we do this with the floor of x or u or whatever the variable is, it's just going to give us the lower bound. So this one's going to evaluate to 2. And then over here, this is going to give us our lower bounds. It's going to round down everything between 3 and pi is going to get rounded down to 3. So this becomes just a constant value of 3. So now that these are constant values, I can just bring these outside of the integral. So then for this, we're just going to bring out ln 2 for this same integral from 2 to 3. And then I'll write this as u to the minus 2 because we're going to use power rule on that. And then here we'll take ln 3 outside of the integral, integrating from 3 to pi, and again, u to the minus 2 du. But then using power rule to integrate this, this is going to be minus u to the minus 1, or I can write this as minus 1 over u, and it's going to be, of course, the same thing right here. So when I go ahead and combine this with the natural log 2 in front here, so for this first term, we're going to have minus natural log 2 over u, evaluated from 2 to 3. Here for the next one, same thing, but we're going to have natural log of 3 over u, and this is evaluated from 3 to pi. And I think what I'll do is just factor these minus signs outside of everything here, so we can just try to simplify this, and then we'll plug in. So for this first piece, for this first integral, we're going to have natural log 2 over 3 minus natural log 2 over 2. Then for our second integral here, this is going to become ln 3 over pi minus ln 3 over 3. Then I just need to simplify. Let's get a common denominator here. So I can write this as 2 over 6, and I can write this as 3 over 6. Then putting these terms together, we're going to have natural log 2 over 6. And we'll have a minus sign in front, but we have minus times minus, so this is just going to be positive ln 2 over 6. And then here I'll distribute the minus sign into this first term, so minus ln 3 over pi, and then minus times minus here is plus ln 3 over 3. And I think I will try to simplify just a little bit more. So what I'll do is try to get a common denominator with this 3 and 6. We'll have ln 2 over 6, and then we'll create this one over 6, so we'll have 2 ln 3, again over 6, minus this ln 3 over pi. But I could take this 2 into the exponent on the 3, and so then this becomes natural log of 9 right here. But by log properties, I can combine ln 2 plus ln 9 and multiply them and get ln 18 over 6 minus ln 3 over pi, and that's it. Okay, there you have it. Interesting problem from MIT 2006. Thanks everyone for watching. Have a good day.